Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals. And in this session we are going to establish this important inequality involving definite integral. That is, we have to show this inequality using the properties of definite integrals. So here we have to prove that pi over 12 is less than or equal to the definite integral pi by 6 to pi by 3 cosine x dx, and that is less than or equal to pi root 3 over 12. So viewers, this inequality can easily be established using an important property of definite integrals. So let us first see the statement of the property. That is, if we have a continuous function, say y is equal to f of x in the interval that is a comma b, and if x it lies between a and b, and if small m denotes the minimum value of f of x in the interval that is a comma b, and capital M denotes the maximum value of the function f of x in this interval a comma b, then we can write this inequality, that is m times b minus a is less than or equal to the integral that is a to b. Here we have f of x dx, and this is further less than or equal to capital M times b minus a, right? So here this is an important property of definite integrals, where this integral, that is integral from a to b f of x dx, the value of this integral lies between these two numbers, right? So here this small m denotes the minimum value of f of x in this interval, and capital M denotes the maximum value of f of x in this interval, and here m times b minus a is less than or equal to this integral, and which is further less than and equal to m times b minus a. So now let us utilize this property to arrive at this inequality. So let us compare this integral with this one, that is integral pi by 6 to pi by 3. Here we have cos of x dx, and here we have the integral a to b f of x dx, right? So if we compare both the sides, we can easily get a is equal to pi by 6 and b is equal to pi by 3, and our function f of x is cosine x, right? Okay, now let us first see the nature of this function cosine x. Now if we find out the derivative of the function, that is f prime of x, then we can have here a negative of sine x. So the derivative of cosine x is negative sine x, and we can easily see that this quantity, that is negative sine x, is always less than 0 for all values of x belonging to this interval, that is from pi by 6 to pi by 3, right? So we can conclude that the derivative, that is f prime of x, is less than 0, and this is the condition for a function y is equal to f of x to be strictly a decreasing function, right? So the function cosine x is strictly a decreasing function in the interval that is 0 to pi by 2, right? So in the first quadrant the cosine function is strictly decreasing function. So here we are given this interval, that is pi by 6 to pi by 3, and this interval is a subset of the interval that is from 0 to pi by 2. So now let us quickly see the graph of cosine x. So here we have y-axis, here we have x-axis. So the graph of cosine x in the first quadrant, it goes like this, and here we have plus 1, and here we have minus 1, and here we have pi by 2, and here we have pi, right? So the graph of cosine x from 0 to pi by 2 is given by this curve, that is from here to here, and here the interval is given as pi by 6 to pi by 3. So pi by 6 lies somewhere here, and pi by 3, it lies somewhere here, right? So here we have pi by 3. Pi by 3 is 60 degrees, and pi by 6 is 30 degrees, right? So here the value of cos pi by 6 is given by this number, and the value of uh, cosine pi by 3 is given by this number. So now from the graph of cosine x, we can easily conclude that cosine function is decreasing function from 0 to pi by 2, and the maximum value of cosine function in this interval, that is from pi by 6 to pi by 3, it occurs at this point, that is pi by 6, right? So capital M is the maximum value of f of x, and f of x is cosine x, right? So the maximum value occurs at this point, because this ordinate denotes capital M, and the minimum value of cosine function is given by this ordinate, that is small m, right? So here the capital M is given by cos pi by 6, and small m is given by cos pi by 3, right? So this is cos 30 degrees, and cos 30 degrees is square root of 3 over 2, and cos pi by 3 is cos 60 degrees, which is equal to half, right? So capital M is root 3 over 2, and small m is equal to half. So now let us find out the value of this quantity, that is b minus a, that is the difference between b and a. B is the upper limit and a is the lower limit. So b is given by pi by 3, and a is pi by 6. So the LCM of 3 and 6 is 6, and here we have 2 pi, here we have pi. So this is pi over 6, right? So now we have the value of capital M, small m, and b minus a. So let us substitute these values in this inequality. So here we have half, then b minus a is pi over 6, then we have the integral a to b. A is pi by 6, b is pi by 3, and here we have cos x dx, and here capital M is root 3 over 2, and b minus a is pi by 6, right? So this is pi over 12, and here we have pi by 6 to pi by 3 cosine x dx, and here we have pi root 3 over 2 times 6 is 12, and this is our required inequality. So viewers, this is how by using this important inequality of definite integrals, we can easily establish these kind of inequalities.